Hello, all. So today we are going to be talking about determining limits from a graph. So limits from a graph. And before we get started, I want to remind us of our notation for limits. So a little bit of review of notation. Recall that we have a left-sided limit, which is written like so. So x is still going to approach some value c, but we say it's approaching from the left with a little minus for some function f of x. And then we have right-sided limits. And you can guess what the notation is here. Say x is still approaching c, but I want to approach it from the right side, and I put a little plus. Now, what do I mean by this? Again, just a little review. Say my c value is 2, so I have 2. If I wanted to approach from the left side, that would be choosing like 1.9, 1.99, and approaching the value 2. This would be my left-sided. So letting x approach from the left. If I wanted to approach from the right, that would be like 2.1, 2.01. Stuff just a little bit bigger than 2, and this would be approaching from the right side of 2. So those are my left and right-sided limits. Now, some other little bits of information that we're going to need to recall for this. My first one is that if my left-sided limit, approaching some value c, is different than my right-sided limit, and what does that tell us? Well, that tells us that the limit at c does not exist. So my actual limit as x approaches c does not exist. And most people write it as this capital DNE, so I do that as well. So I'm going to keep it that way. Okay, so if from the left side and the right side, they don't approach the same value for f of x, then the limit doesn't exist. Of course, then that means if they are the same, so my left-sided limit is the same, so it equals my right-sided limit. What do you think that means? Well, then certainly the limit as x approaches c exists, and in fact, it is this value that is equivalent here. So maybe the left-sided limit is 7 and the right-sided limit is 7, then that means the actual limit itself is also 7. So then this would be the same as just my limit as x approaches c. All right, so remember, if they aren't equal, it doesn't exist. If they are equal, it does exist, and that is the value. Right now, let's do some examples. And let me speed it up while I draw our picture. And let's draw our curve in blue, just so it's a different color than my little tick marks. Then go ahead and assume for this XY axis that each tick mark represents 1 unit. Let's call this guy f of x. So this is the curve that we're going to be determining some of our limits from. And I forgot a point I wanted to put right here. Now let's go ahead and determine some limits based off this graph. And don't forget the stuff we talked about here at the beginning, where if the left and right-sided limits are different, then the limit doesn't exist. If the left and right-sided limits are the same, then the limit does exist. So let's go ahead and find the limit as x approaches 2 from the left for this function f of x. And for this first example, I want to make it clear what we are asking ourselves when we see this. So here's our question we're going to ask ourselves. When x approaches 2 from the left, what am I actually looking for? I want to know, what does the y value approach on my curve? So what does my y value approach on the curve? So at least that gives you the idea of what you're actually looking for when you try to figure out this limit. And we need to emphasize one more thing, which is that we say x approaches 2 from the left, and what does y approach? Okay, so we need to be careful with this word approaches. It means when x gets really close to 2. Aha, so we have to be careful. I'm not actually asking what happens when x is equal to 2. We are approaching 2 from the left side. Similarly to all the way at the top here when I drew this number line, if I wanted to approach 2 from the left, my x value, that would be like 1.9, 1.99, 1.999, and I keep inching my way closer and closer to this value of 2, but we don't actually reach the value 2. Okay, so let's keep this in mind when we go to determine our limit. So I'm going to find when x is equal to 2 on my axis. That would be right here, right? And let's look at what's happening to the curve near x equal to 2, and I want to approach from the left side. So I'm approaching from the left side on the blue curve. So here, I'm approaching from the left closer and closer and closer and closer and closer to 2. I never quite reach 2, meaning I never quite reach this hole. And so if I'm just looking at what the y value approaches, it approaches y equal to 2. Right, so hopefully you're with me. It's okay that there's a hole right when we reach x equal to 2 because we're not supposed to actually get there. We're just approaching x equal to 2, getting closer and closer and closer to it. And as x approaches 2 from the left, the y value approaches 2 as well. And I'm gonna erase here. Now let's determine our right-sided limit at 2. Same idea. I want to look at the curve when x is equal to 2, but I only want to approach that value from the right side. We use green this time. So this is when x is equal to 2 right here. I'm going to approach it from the right side to get closer and closer and closer and closer to 2. I never quite reach 2. That's where this point is, but I get really close to it. And when I get really close to x equal to 2, my y value is very close to 4. Aha, now if I put this information together, I now know that the limit as x approaches 2 for this function does not exist because the values are not the same. This is because left and right-sided limits are not the same. Okay, let's try some more using the same graph. Let's find the limit as x approaches 1 from the left, the limit as x approaches 1 from the right, and we're going to use this information to tell us about the limit itself just when x approaches 1. So when is x at 1? That would be right here. And so let's approach from the left side. Let's use more colors. Let's use blue. So I don't want to quite reach when this is equal to 1. I just want to approach it from the left side. So I'm going to start like over here, and I'm going to get really, really close to when x is equal to 1. I never quite reach this hole. It's just approaching that value. And as I'm approaching that value, I see that my y value right here is approaching -2. Okay, now what if I approach this from the right side? So again, I'm interested in when x is equal to 1, but I'm not going to quite reach x equal to 1. I just want to approach it from the right side. So I'm going to approach it from the right side here, closer and closer and closer and closer. But remember, we never quite reach 1. So it's like I stop right before I get to this hole. And as I get really, really close to the hole, my y value is approaching -2 again. Okay, so a couple things. One, because the left and right-sided limits are the same, that means that my limit at 1 exists and it is -2. And if we're looking at the picture, we're learning some information about when our limit exists and when it does not exist. So this is the little phrase that my instructor used to say. He would say, if they kiss, then it exists. So first of all, if it's just a nice smooth curve and say I want the limit right here, certainly the limit would exist because this is like a closed mouth kiss. Now say they meet at a hole somewhere, but they still meet at the same spot. The limit still exists because this is like an open mouth kiss. Yes. But if I have a hole and then like a jump to another spot, or the alternative, it could have a closed dot and then a hole that jumps, then it does not exist for either of these because the curve doesn't kiss there. So again, if they kiss, it exists. That's the phrase we're going to use. Because it starts to become second nature. Like you won't have to necessarily, unless your instructor asks you to, you probably won't have to write down like what's the left and right sided limit. You can just visually see that here they meet and the limit is -2 because the y value approaches -2. Here they do not meet, so the limit doesn't exist. Let's think about one more. About the limit as x approaches, let's say, -3? So here we're trusting our eyeballs, okay? I'm not going to check the left and right-sided limits. Well, I am, but I'm just going to do it in my head. So first I'm going to find on the x-axis when x is -3, that would be right here. And does our curve kiss at this portion or not? Right? It does kiss, right? It's a nice smooth curve. It kisses there. And so I know that the limit should exist. And all I'm going to do is come up from -3, find where that point would be, and I see that my y value approaches 1. So my limit here would be 1. Okay? And let me just add this in because I forgot to mention it. I drew my curve in such a way that I had a hole here at 1, but then it gets filled in down here. Notice that that does not affect our limit because our limit is only approaching 1 from the left and right. Again, it never quite reaches 1. So even though the function is actually equal to -4 right here, the limit is still -2 because that's the value that it's approaching from either side. And if you're thinking to yourself, well, Haley, that seems a bit strange. That should be dealt with somehow, right? It sure does, but it's not going to be dealt with until we talk about continuity. All right, so I am going to stop us there because we saw one of each type of these other than an infinite limit.